All right, 5.4 notes. You should be able to find this. To do a quick review, because I moved part of 5.4 up earlier in the year, just remember, we'll review it real quickly. If you want to do the derivative of e to the u, it's just e to the u times u prime. So, go ahead and try example 1, A, B, and C. This is review. This is what you've done before. But you have to remember the chain rule, okay? Don't forget the chain rule. The other thing, do not forget to write y prime or dy dx, because if you go from y equals and all you do is write that down, it would be marked wrong on a free response because you have no indication that you did a derivative, okay? So just, tidy that up. Now, in letter B, if you have e to the negative x, for the most part, don't leave a negative exponent on a multiple choice. It won't be left that way. In C, we have the product rule. Don't forget that. Now, something they'll like to do is they'll factor out that e to the negative 2x, and then they'll drop it down. Okay, you guys remember this? No problems. Okay, so now what we're going to do is integrals of e to the x are very, very similar. The integral is still e to the x, but if it's a u, you're going to have to do a u substitution. So we're going to love this section, honestly. Thank goodness. All right. So here we go. Number 1, if I have the integral of e to the x dx, it's just e to the x plus c. And if it's e to the u du with some stuff, you must use u substitution and take care of that, okay? So, in example 2, if I have the integral of 3 to the x plus 1, I don't have just e to the x, so I'm going to do a u substitution. So, I get du equals 3 dx. I have the dx, but I don't have a 3. So, this becomes 1/3 the integral of e to the u du. So that's 1/3 e to the u plus c, which is 1/3 e to the 3x plus 1. Sorry about that. Plus c. Sorry, that's 3x plus 1. Do you guys see that? That it's really not bad. Not bad at all. Alright, so let's look at example 3. Alright, this one looks a little bit more complicated. However, if I let u be negative x squared, du would be minus 2x dx, and I have an x dx, right? And that 5, I could just pull a constant out. Okay, so a constant can always be just pulled straight out. So then I've got negative 1/2 du equals x dx. And then watch how I can rewrite the integral. Do you see where the negative 5/2 comes from? Okay, that's the 5, and here's my negative 1/2, and those will just go out front. And then look how nicely and neatly this simplified to the integral of e to the u du. Like, wow. Okay, so then that's just negative 5/2 e to the u plus c and we'll back substitute. E to the negative x squared. All right, try example 4. These are getting like to the toughest type that you'll see. Still not bad, but think about what do you want to let u be, and do you see the derivative somewhere, okay? So think about it. Try A and B. I'll give you a moment. So do you see you have the 1 over x squared dx? We don't have the negative, so we do have to bring that over. So then this becomes negative the integral of e to the u du, which is just negative e to the u plus c. Okay, not bad. And then what did you let u be in letter B? Cosine x. Good. So if u is cosine x, we see du. Now be careful. The derivative of cosine is negative sine. So this will be negative the integral of e to the u du. So it's negative e to the cosine x plus c. Okay? All right, any questions on this? This really is a nice... Yay! You like this? Okay, last example. Finding, I think it's the last one. Yeah, the last one. Finding the areas bounded by exponential functions. This is just a definite integral. Something I need you to remember is e to the x, unless you shifted it up or down, like it's always above, or if you e to the negative x, that just does this. Okay, without a calculator, you should know this. We did it in Algebra 2, we did it in pre-calculus. So there's an expectation, you know what that looks like. Then if I had negative e to the x, let's review this one. Okay, that's this one with a negative out front. That's going to reflect it down. Okay, and then what would negative e to the negative x look like? It's going to be this one that got flipped down. Okay, you see how you can just sort of reason that out. Okay, so when they're asking you to find an area, it's, you know, either all positive, this is all negative, and it's always bounded to the x-axis. So what we're going to do is, if I want to evaluate the integral from 0 to 1 of e to the negative x dx, so that's still above, so I don't really need to worry about a part that's above or below. Okay, when you're talking area, we will learn that in chapter 7. We'll talk about areas and be more concerned with that. But for now, let's do a u substitution because it's not just x. So if it's not just an x, you need u substitution. Du is negative dx, so I'm going to put a negative out front. So this will be negative the integral of e to the u du. However, now you have two options here, and let's just keep the options straight. Either you integrate and don't put the limits in, and then when you're done, put x back in and do it from 0 to 1. That's one option. The second option is change the limits of integration. I'm going to go ahead and change them here. If I started at 0, negative 0 is still 0. And if I plug in the 1, that's now a negative 1. I should notice that the limits of integration are backwards. So when you flip it, what do we have to remember to do?
Make it negative.
Make it an opposite. Well, the opposite of a negative is positive, so that was a good option for us. So then that's e to the u. Now you're not doing a plus c because we have a definite integral. So that's e to the 0 minus e to the negative 1. Let me show you two ways to do this. If this is no calculator, this is 1 minus 1 over e. If you have the calculator section or the, and the multiple choice answers are decimals, then you just pop it in your calculator. And I got 0.632.
And you can't do it the other way?
What's the other way?
I went straight from that. I just kept the 0 to 1 and then had negative e to the negative x from 0 to 1.
Okay. I'm not sure if you didn't hear me, but what I said is you can do it without the limits, okay? And you could have your e to the u, okay? But then you have to plug in your negative x and then go from 0 to 1, okay? So that's your e to the negative 1.
So you have to put it as negative in front of it?
Yeah, sorry. Yeah, we lost the next.
Yeah,
So
that's
wait a
where
minute.
I am right now.
Yeah, and then you'd have minus 0, and then do you see that in fact is the same answer?
Oh, yeah.
Yeah. Yeah. So that is the same.
Okay.
You may do that, but Sam, be very, very careful on this piece here where you are first doing it with a u, because you have to do it with a u. Don't put the numbers there because it's not 0 to 1.
Right.
Like that's wrong. But we kind of leave them out, put x back in, and then you put your 0 to 1. Okay?
Yeah.
All right, try B and C now. Okay, I'll give you a head start on me. Try B and C.
So the derivative of e to the x is just e to the x?
Yes.
I knew that.
Remember, we just reviewed it at the beginning of the notes. And then let me talk about the limits of integration, okay? If you plug in 0, 1 plus e to the 0 is 1 plus 1. That's where my 2 came from. When you plug in a 1, that's 1 plus e to the first. Now that's not pretty, but that's it, okay? So now, you guys, do you remember what's the integral of 1 over u du?
Natural log of
Awesome. Okay, natural log, absolute value of u. And this is from 2 to 1 plus e. So this is ln. Now, do you guys understand that 1 plus e is positive? So I don't need the absolute value on that one. Minus, and 2 is positive. That's a correct answer, and I want to make sure nobody's trying to do a major mistake here. ln 1 plus e is not equal to ln 1 plus ln e. What I think you're thinking of is we have a property, oops, ln a. We have this property that says the ln of a product equals ln a plus ln b, but there's no product property for ln a plus b, nothing for that, okay? So you would stop here, or the decimal answer I got was 0.620. All right, continue with C if you haven't
What's
done
E
it.
like about? What's E like almost?
2.718.
Did they expect us to know that on the exam? Without a calculator?
Not without the calculator.
Okay.
Okay, now, Nathan's asked a really good question, and I guess I should reconsider my answer. Like, e to the negative 1 means 1 over e. So you need to think about, is this smaller or bigger than 1? If you're taking 1 over about a 2.7, I mean, you could even round it to 3-ish. 1/3 is 0.33. And even if you round it to 2, 1 over 2 is 0.5. Do you understand that really is still the smaller number? So that would be a reasonable expectation. Just remember E is smaller than pi. If you can remember that, you'll know enough. Like, they would not give you something that's like 0.99 and you'd have to figure that out with a calculator. No, they're not going to do that to you. Okay? All right, now, what's the integral? Because some of us got this a little bit mixed up yesterday on the quiz. What's the integral of cosine? Is it sine or negative sine?
Negative sign.
No.
It's not negative.
Oh, good. Well, that might have done it.
Oh, because
Sine
it's
u is negative
in-
cosine.
Yes, the integral of sine is negative cosine. And here's how I do it, because I do struggle with that one, is I write it down. I'm like, okay, I know it's sine. Is it positive or negative? And what I do is I take the derivative of the sine. And that gives me cosine. It's it. So when I'm doing the integral of sine, okay,
But on B it was.
I do cosine, and then I say if I took the derivative, that'd be negative sine. Oops. That's how I do it, okay?
Back on problem B,
Yes.
I mean, on example 4,
Yes.
we did that cosine was equal to negative sine.
Wait, that's the derivative.
And derivative is.
The derivative of sine is negative
That's
cosine,
why I was
but
talking
now I'm
about
doing
that,
the
too.
integral, okay?
Okay.
I know, it's hard to keep that straight. You're not crazy. That's a tricky one. Okay, now this would be a correct answer, sine 1 minus sine 1 over e. Or, and you guys, this is, they love to give you problems like that on the no calculator, because they want to know, do you know what you're doing? Some of us are calculator happy, and we're not thinking as much, and they want to know, you're just plugging in, you put the 1 first. Like if this were multiple choice, they'd have sine 1 over e minus sine 1 as a wrong answer choice, okay?